And for that, you open up the robot editor. First time you run it, it'll actually look for a Java compiler and see if it can use that. So this one says, yes, I found a working Java compiler. Should I use that one? Sure. Let's use that one. If not, it has one built in as well. So robot editor is not what you think it is. It's not a drawing program that allows you to draw your robot. It's it's really a programming editor. So enter the name of my new robot. So one of the requirements is you should give your robot an original name. So examples of non-original names are Terminator, Killer, Destroyer, any of those things. I don't know. Ballerina 1298. And actually, here's something I care about. I would like you to put this in the package called comp 1405. So it asks you for a package name. And so one of the things in Java we saw is when you import stuff, you're importing it out of you import a class from a particular package. For example, java.util is a package that contains things like set and list. Java.io is a package that contains things like file readers and so on. And in general, every class that you create should be in some package. It's not a good idea to have a class outside of a package. And I would like you to use comp 1405 as the package name. Okay. So it gives us a skeleton robot. So let's see what one of these things is. It's just a Java class. It belongs to the comp 1405 package, and it imports everything that's in Robocode to make in the Robocode package to make your life a bit easier. So it's called Ballerina 1298, and this is something we haven't seen before, but this is basically how you do inheritance in Java. So it says this extends robot. So in the Robocode package, there's a class called a robot, and we're saying that this is a subclass of this class. And that means that it inherits all the methods that are in robot, so there'll be all of these methods we can use. So that's the way it works. And of course, the main method is the run method. So this is what controls your, this is the entry point for the code for your robot. You initialize for a while, and then you typically have a infinite while loop that controls the robot forever. So it's an example of one of many kinds of applications where you really want an infinite loop. Usually you avoid them in code, but systems that run forever, or ideally run forever, should be inside an infinite loop. And a robot is such a system. A server, an internet web server, for example, is such a system. So there's a place for infinite loops. And actually, this looks like the code for my first robot. So the code says, go ahead 100, turn the gun right 360 degrees, then go back 100, and then turn the gun right 360 degrees. Repeat that for forever. So if we look at this, let's restart. Actually, let's take some of these out. We'll keep maybe sitting duck and my first robot, and see if he's really doing what this code says. So forward 100, right 360, back 100. Forward 100, right 360, back 100. So that seems to be what he's doing. But there's something else in here. He's also firing at sitting duck. Okay. So why is that happening? Well, there's nothing in here that says anything about firing. And that's happening because there's another method that this thing implements called on-scanned robot. So what is this method? Well, this is a method that gets called when this thing sees a robot in front of its radar. So when this thing turns 360 degrees, so does the radar, and so at some point, actually, this thing is sitting right in front of the radar, and that triggers this on-scanned robot event, and the way it handles this event is to fire. So it fires once. Okay, so that's fine. And let's go with, where is he? Put tracker in and get rid of sitting duck. So there's something else that happens there in my first robot. So what's more than we've seen so far? What's happening? Yeah. So he doesn't just go back and forth, sometimes he turns. And that's again because there's an event that's associated with being shot. On hit by bullet is the name of the event. And so there's a method that gets called by this thing. And when that happens, this thing goes back by 10. Okay. And there's another event actually when it hits a wall, it goes back by 20. Now, does that explain everything that's happening? Not really, eh? So I didn't see any code in there for turning. So maybe the my first robot code is not completely in there. Right. So this guy actually turns when he gets shot, and I don't see code for that in here. Okay. So anyway, this is pretty much what my first robot does. The first and most important thing you have to do is pick colors for your robot. And so for that, you want the colors available. And the first time we save something, it'll ask if we want to create the directory. Say yes. I don't know what happens if you say no. So what colors should we use? Well, let's look. So there's a bunch of named colors: black, blue, cyan, gray, green, light gray, magenta, orange, pink, red, white, yellow. But you can also, yeah, great, that's over. You can also create colors, any color you want as well in RGB. So what should we use? I don't know. Somebody pick some colors for me. Orange and white. Orange for the body. And gun should be white. Maybe the radar too. So, okay, now we've got a color for this guy. So there's two things you do with these files. You save them, but you also compile them. So I've been doing Control S just to save, but you also can do Control B to compile this thing. And it's not until you, okay, that's interesting. I didn't get that warning on my other system, but hopefully that's not a big deal. So it says it compiled successfully, and actually this is something something interesting. The code, it shows you the code size, and this is one of the first features, of the most important features of Java when it was when it was first developed, is that it generates extremely small code. So this is a class file that has 71 bytes in it. That's tiny, right? I mean, it's much shorter than the source code. And actually, so Java is a good language that gets used a lot in things like embedded systems, precisely because those systems are memory constrained, and Java programs tend to be very small. In fact, the whole Java virtual machine was designed to make Java programs as small as possible once they're compiled. Okay, so let's run this guy in a tournament. Comp 1405 Ballerina. We'll add him and see how he does against my first robot and sitting duck. So he's looks a bit more yellow than orange, but whatever. That's what they call orange. He didn't last very long. We can restart and see. So actually, he's pretty good because he managed to stay out of the fray, and Tracker went after the other one. Yeah. So, not great against things like Tracker. Okay, so well, now it's totally up to us what we want these robots to do. So I don't know. Somebody give me a strategy that we can try and implement.
It circles around the robot when it gets to it.
It circles around the robot when it gets to it. Well, how does it get to it?
Oh, we're not into it.
Yeah, okay. So when it scans a robot, what? What should we do? Yeah, so there's a lot of variables here, right? So this is actually an interesting thing to do because, you may not be interested in killer robots, but it shows you actually how difficult it is to make a non-killer robot do anything clever. So robots, and it shows you actually how good we are as people at being smart. So robots are really dumb things. They have a very limited view of the world. These ones are really simple. They only have this radar gun that lets them see what's directly in front of them. And it's actually really hard to do things with only that much information. So let's start with something really simple. Really, really simple. It turns. Okay. So let's do something like so what's this robot going to do? So it'll go drive forward and then it'll turn right. And it'll repeat that. So what does that do?
Well, it's going to drive forward, turn right, and then keep it while it's doing that spin. It's done over and over, and now let it try it.
So no spinning its gun. Well, let's see. If we repeatedly drive forward and then turn right, we may hit the wall. Let's restart. keeps bumping into the wall, and now he's pinned by these guys.
Hanging up on it.
Yeah. So let's try that again. So it's actually, when it's in the clear, away from other robots, this is actually not a bad strategy. Because, well, Tracker can't actually get him. By the time Tracker lines him up, he's gotten out of the way. So it looks like we have a stalemate here, right? Well, there's no reason that ours should hit a wall now. So ours is tracing out a figure with 360 divided by 30. What's that? Oh, you got him. Finally got him.
Well, right now he's not even shooting anyone.
Oh, yes, he
There
is.
we go.
If he happens to line someone up, he'll take a shot at them. But it's really it's a powerful strategy against Tracker. And it's even not bad against my first robot, except that occasionally the two, this ballerina robot runs directly away from a bullet, which is never a good thing to do.
Or get stuck in a wall.
Or it gets stuck in a corner. So getting stuck in a corner is something we can reduce that a little bit, because it's trying to trace out a pretty big figure. Maybe we should go with a smaller one. Oh. Really not doing well. Didn't do well there. Bad starting position. So it seems to do okay as long as it doesn't get too, oh. Yeah, and it's not running fast enough for Tracker, to get away from Tracker. Yeah. Okay. So there's our first simple attempt. Didn't work out so well. Or didn't work out fantastically. What else could we try and add here? So maybe we should go and look at what tools are available to us. So the hard part of all this, I mean, it's very easy to think of a strategy which is like, oh, you know, pick a robot and then chase him around and shoot him as much as possible. But you have to be able to implement that using what's available to you. And so if we look at the Robocode API, so recall that our robot that we're developing is a subclass of robot. So whatever's in robot is stuff that we get to use. So we should take a look at robot. And not every robot you develop has to subclass this robot. There are more sophisticated ones you can subclass. So this is one of the simpler ones, just for getting started. Okay, so you construct a new one. So ahead we've seen, move forward a certain distance. Back we've seen, move back a certain distance. Do nothing. So this just says, well, exactly what you think it says. Don't do anything right now. It's important to call do nothing if you really intend to do nothing, because the way that this whole simulation is implemented is each robot basically gets a turn. And you know, a turn is just is a short slice of time that its code gets to execute. And And if you just have a while loop with nothing in it, well, that sort of just, rather than skipping your turn, all you're doing is consuming a bunch of CPU cycles. And that's kind of not nice for the rest of the simulation. Fire, so you immediately fire a bullet, and there's something here about power. We can look at see what that means. Bullet will travel in the direction the gun is pointing. There's firing takes a certain amount of energy, and power tells you how much energy to put into it. The more power you want to spend, the more energy you take, and power controls how much damage it does. So you can think about that. And it seems guns in these machines get too hot after a while, and so you can't fire if your gun is too hot, or maybe you melt the gun down. So if get gun heat returns a value greater than 0, you're not allowed to fire anymore. And we can test that out if we try and fire all the time. At some point we shouldn't be able to. Oh, I forgot to compile. So here we try and fire on every round. It's probably not going to save us against tracker. Okay. Where'd you go? Where did you go? We want there. So other things we have to work with. We can all right. So fire bullet seems to be the same thing, except that fire bullet returns a bullet object, which maybe you can do something with. So it's exactly the same interface, and it returns a bullet that contains information about the bullet that was fired, and you can, it seems, track it. Bullet. What can you do with bullets? You can figure out its power, its velocity. You can actually know where the bullet is at any point in time, and see if it's still flying or if it's already hit something and disintegrate it. So so you can shoot and see if you've got if you were successful, and in fact you can get the victim of a bullet. So if it did hit something, you'll get to know the name of the robot that it hit. So get the battlefield width, get the battlefield height. That might be useful. One thing I will probably do is not just use 800 by 600 things in testing. So you may want to scale some of your stuff based on the width and height of the battlefield. Figure out how much energy you have left. So maybe you want to change what you do depending on whether you're almost dead or not. Maybe you want to go kamikaze at the end. So some stuff about your gun cooling rate, where your gun is pointing, which direction. So I believe 0 is straight up, and so 180 would be south, straight down, and so on. How hot your gun is, get your current direction, get the height of this robot. measured in pixels. Not sure why that's, well, I mean, I guess it's useful, but it's probably not something you'll use. Get your name. How many rounds has the current battle been going on for? And here's a useful one. This tells you how many other robots are left on the playing field. So sometimes maybe a strategy is to, in fact, a good strategy maybe is to just run away from everyone until there's only one robot left, and then turn around and kill it. So that's something we could try and implement. Get the number of rounds, get the time, get the current velocity. And here's a bunch of events. These are actually the important ones. So when the battle is over, this gets called. When you're hit by a bullet, this gets called. So you should do something differently maybe when you get hit by a bullet. When one of your bullets, oh no, sorry. On bullet hit is when one of your bullets hits another robot. And on bullet hit bullet is when one of your bullets hits another bullet. So maybe, I don't know, you could imagine some strategy where you try and shoot down bullets that are coming at you, but that seems difficult. This calls when you don't hit another robot with your bullet. When you die, this gets called. And on hit by bullet is when you're hit by a bullet. On hit wall, when you hit a wall. On hit robot, when you hit another robot. On key pressed, on key released, on key typed. Those we don't want. On paint, one thing you could do if you're more interested in the artistic aspect of this is have your robot render itself in a different way, so you can actually paint it yourself rather than just use the colors available, the change of colors. When another robot dies, when a round ends. On scanned robot is one we've been using. So when your robot's radar scan or when your robot's radar is facing another robot. On status, on win, resume, run, scan, nothing. Run, we know this is what you have to override to make your robot do what you want it to do. Scan, scans for other robots. So what does that do? It's called automatically. So it's not one we need. You can also have your gun turn independently of your robot, so you can, by default the gun is facing in the same direction as the robot. You can turn that off, so the gun will just face in the same direction even if you turn the robot. Set all the colors, set the body color, the bullet color. You can do all those interesting things. Stop. Turn the gun left, turn the gun right, turn left, turn radar left, turn radar right, and so on. Okay. So those are the tools you have available to you if you're starting with a basic robot. So somebody suggested some strategies like circle around a robot. Do you know how we would do that? Using these methods. So remember, we have a very limited view of the world. Basically, if our radar is facing a robot, we'll get this event that says on scanned robot. But otherwise, we don't have too much to do. So any idea? Okay, so let's try something simple.